Welcome back to the Population Ecology lecture series. And at the end of the last lecture, I said we were ready to go into Populus. So when you go into Populus, you're going to pick your multi-species models again, look at continuous predator-prey models. You're going to select the Lotka-Volterra model once you get into that input screen. Make sure nothing else is checked in that box. And let's see, we're going to look at, our graph is going to be P versus N, and termination conditions are going to be run until steady state because, again, we're talking about equilibrium conditions. So if you do that, you should end up with a graph that looks like this with a couple of lines. Okay, so at 10, you should see this pink prey line go up, and at 13, you should see this blue predator line go over. And so remember, what we're looking at is equilibrium densities, and so these are Zinges. This is the point at which the predators and the prey have zero net growth. And so we can actually look at these lines as representing these two equations. So we can look at the predator line and see that it corresponds with this 13. And we can look at the prey line and see that it corresponds over here with the 10. Okay, so that means that if we want to keep the prey at zero net growth, we have to have 10 predators. That means that if we want to sustain zero net growth instead of decline or overabundance so you get growth, for the predator you need 13 prey. So that's what those numbers mean. Okay, so what we can do is we can now divide these Zinge graphs into zones. Excuse me one second. Okay, so let's start talking about these zones over here at zone 1. So, of course, at this zone we have lots of prey and we also have lots of predators. So with abundant food to eat, those predator populations are going to increase. And that increase is going to lead, of course, because they're feeding on the prey, into a decline in the prey until they get into zone 2. Now, zone 2 means that prey are reduced to a level that, below a level that will sustain those predator populations. And so predator populations start to decline as we see these prey populations going down. Now they decline enough that we start to see a growth in the prey populations once we get into zone 3. So we start to see those prey grow as the predators are declining, leading them into zone 4, where both populations increase until they're back at zone 1. So we see our predators going up, and we see our prey going up as well. Okay, so that makes pretty good sense, right? That this, if we're defining predator and prey populations as really defining each other's Zinges, then these are the kind of dynamics we would expect to see. Okay, so the last thing I want to do in this video is just talk about what happens over time with these predator-prey models. And so if you switch your graph to be P and N over time, what you should see is something that looks kind of like this, where your prey populations are kind of oscillating up and down and your predator populations are following them. So this is something that Should make sense to you why people sometimes say predators will track their prey. And it makes sense given that we've really defined these two groups by each other's population growth parameters. So what I want you to do right now is just go through in Populus and change some of those parameters that we put in. Change the starting population sizes, the encounter rate, change the consumption rate of the predator, the starvation level of the predator, and see what happens to the models. And then we'll come back to add some more reality into them, and see you soon. Thanks for your attention. Bye.